Welcome everybody to the latest in our series of webinars at ServicePower. I'm Brad Hawkins. I'm the Chief Product Officer at ServicePower, and I'm joined today by Ziad Kilbousi, who is our Vice President of AI, was part of the recent acquisition of Invenium, and one of the team members you've heard me chat about on other webinars about. We acquired this super talented team, and today we want to focus on AI, obviously, but what we talked about was the idea of the art of data science. It is a skill that, from a ServicePower perspective, we feel we acquired as part of this. We've got a really talented data science team. Those teams are led by Ziad. So Ziad, I'm going to give you a chance to say hello, talk about your background a little bit, and then we'll get into some questions as it relates to data science. So introduce yourself.
Thank you very much, Brad. So for the introduction, my name is Ziad Kilbousi. So I built Invenium together with Ahmed Gourbal, basically developing computer vision models for real life challenges like on field quality assurance, for example. We worked closely with customers to meet their demands and requirements, all delivered through AI and computer vision. So after a couple of years, we of course got acquired by ServicePower, now ServicePower, mainly because our businesses basically meet pragmatically, where ServicePower, being already a leader in the ServicePower in the field service industry, it feels just natural to integrate AI capabilities with computer vision, to augment the service offering they already have.
Yep, great, and we're super happy to have you on as part of our team. Let's start then with AI and data science. As AI was really getting traction and the hype was at its highest, we started to talk about something that, I jokingly called the great data cleanse that was going to go on, because in my opinion, AI is only as good as the data behind it. So from a data and data science standpoint, what in your opinion is, how do you suggest in an AI world you start with good data? What is good data? What is good enough? How do you get that ball rolling on ensuring you have good data?
This is a very good question, Brad, and I'd like to highlight the fact that building training models today is not really as much to bring value actually to the real world. I mean, something that gets used and actually has an ROI, has value. It's not about the model architectures or extremely advanced tweakings here and there. It's really about the data you actually train your models on. There's a very known saying which says trash in, trash out. I mean, no matter how clever your model architecture is, it basically revolves around the quality of the data you feed the model. When we work in a real world setting, and in examples we have worked on, the data really which is ingested by our models is really diverse. It's really noisy. You've got technicians in the field, everyone's got his own phone, different camera settings, different resolutions. You've got a lot of variety, a lot of noise in these pictures. And the challenge is to put in place or train a model that is robust to this noise and to these variability and changes. Now, in a perfect world, I mean, you'd start with enough data. Whatever you ask for, you get in order to build that model. But oftentimes what we see, like 9 out of 10 cases, our customers do not necessarily have mature data practices in place. So either haven't started collecting images from the field, or it's really not organized or cleansed, or made ready for training. So the issue is you find yourself working with a constrained set of data, which in terms of volume, in terms of variation, in terms of representing the real world, really. So this is what we tackle day in, day out, the data science team, working with techniques and heuristics that allows us to build robust models, on constrained data sets. And, as soon as the model is deployed in production, we put in place all the monitoring necessary to actually detect any shortcomings, on which we basically react quickly, reintegrate this data into the training pipeline, deploy new models to keep the model, useful, with high performance and answering to, the customer requirement.
Great answer. There's a number of things that triggered for me. And I'm wondering if you can talk a little bit behind the scenes so that people can learn kind of how these models are built. I have seen since you've come aboard that even in POCs, you're collecting, let's take a Vision AI example. We're collecting up to maybe 300 photos, and you're building a model around that has some level of accuracy to it. And I'm curious if you can talk about what is happening behind the scenes. How are they building that model? I've witnessed, in meeting the teams, annotators in the background, the creation of the model, the understanding the confidence level of the accuracy it's producing, and then ensuring there's a feedback loop to that to ensure that it doesn't stray. Can you talk a little bit about under the hood, how that's all happening?
I'm gonna take like a fictitious,
Sure.
proof of concept that we're gonna work through. We've got this customer which usually comes up with a need. So I have a problem. I have my technicians or my operators taking these pictures. Out of this picture, I'd like to make sure X, Y, Z. Right? I mean, an object is there. The picture is not blurry. The count of small objects, needs to match this, or any kind of business rule which can be extracted from the image. So what we do is we basically study the use case, understand what actually is needed in terms of models that need to be trained and created, because usually use cases are not really training one model, right? I mean, you're probably training 2, 3 that you run in a micro workflow, so to deliver the use case of the customer. So the first thing we do is, we look at the images, we understand them. We have sessions with the customers to actually, clarify the any business related, acronyms or jargon, right? So that we understand exactly what we're looking at. Then these images basically, get a batch of these images gets uploaded, to the annotation team. The annotation team has instructions on what to annotate, what information we create in these images, which downstream is directly consumed by the data science team, where they start their real work. I mean, curate the images, define and understand the different image metrics, distribution, understanding if we're lacking variation, if we're lacking if we have a biasing classes, if we any issues with the data set. Because I mean, we have to understand the data set, because when we understand the data set, we know what's missing, what could have an impact on the model performance before we could even start training, right? And that's there's a small back and forth here with the customer, asking if they have what we're missing. If they don't, of course, we need to find ways to mitigate that in the building process. From that point, basically data scientists start a wave of experimentation. So they will, this is basically an experimentation playground. I mean, the sky is the limit. The idea is, let's launch, 10, 15, 100 experiment, lanes, and see who wins, right? I mean, and these lanes basically, we change the model architecture, we change, image sizes, crops, augmentations, and different other hyperparameters as well related to learning, and we track the performance of these different experiments. We understand when we have poor performance, we try to understand. We do error analysis as well, right? I mean, why we're having this poor performance here and there, and the output of this is basically we have a candidate of a couple of models, experiments that are that perform better than others. So that's basically the result of the POC. We deploy that. I mean, and we start, ingesting real data. I mean, subjecting the model to real data from the field. The first, second iteration, absolutely, there's going to be, surprises in terms of data because this is really what is coming from the field. And that's not a problem. That's actually a normal or a natural part of the life cycle. Because once we deploy the model, we basically start to immediately monitor the model outputs. And whenever we see, weak confidence scores that suggest that the model is confused, not really sure what's predicting, we also capture, other signals like the entropy, any anomalies in the number of detections. For example, if you've got a picture where you should be looking at 2 to 10 predictions, and then suddenly you've got 150 predictions. There's probably some anomaly there, some outlier. So we look at all these signals and annotate, reintegrate, retrain, and redeploy. We go through 2, 3, 4 iterations like these as the data is coming in. At the end of the day, the customer basically has a model that is constantly learning and getting better in performance. Right. And this is very important, and we have to actually explain this, time and time again to the customers, because they look at the models as, a software delivery, right? It says, okay, it's delivered and it's up and running, and you can start filing bugs now. But it's not like that. I mean, I think about the model being deployed in production for the first time is actually the birth date of the model, but then this is exactly where it starts living, right? And you start taking care of the model, making sure its performance doesn't tank, over time. Because even if the model is really, top notch, right? I mean, we had all the data we wanted and everything. The data itself is bound to change over time because, I don't know, technician X has acquired a new phone with such a better resolution, right? Etc. Right? So this is a constant, basically, feedback loop that we put in place. We monitor and retrain and redeploy when needed.
I love the comparison and this is great when you consider it in the context of AI in general, that a model is born. It is a living, breathing entity that needs guardrails, that monitors, and it learns over time. Sounds very human-like, which is exactly what AI is supposed to be. So that's awesome. I kind of wanted to mention, there's a couple of recent releases ServicePower's done, and I think it's very relevant to the discussion of data as it relates to data science and what we've done using AI, and that's Contractor Intelligence, which is a service that allows for companies who may not be able to find a service provider that in a particular area or that can run a particular job or may have low performing servicers. And I explain it as it's comparable to the process of me asking something like ChatGPT, hey, I don't have anybody who could run this job. So is there anybody out there you could find for me? And can I know that they are fully compliant? They've been vetted, they've been credentialed. And I also want to know, how do they perform as a service provider? And information can be given to me in that moment to go, how do I save this particular job? Or how do I recruit this servicer that I didn't know about in the future? So there's that. Then we've released ServicePower Chat fairly recently. And I know that name, ServicePower Chat, of course, the ability to chat is not revolutionary, but the ability to capture unstructured data of text going back and forth between consumers, technicians, the enterprise call center, and use those for the purpose of triggering events through AI. Long explanation there, but it makes me think there is a lot of unstructured data that had to be brought together into a data foundation to be able to do that. So what are the considerations of how do we get to, with a data science team, of looking at data in a way that we know it's unstructured and bringing structure to it?
So this is as part of Contractor Intelligence. I mean, we started looking in ServicePower, at different AI initiatives, and we came down to the conclusion that the lifeline of AI, whatever we want to deploy, downstream is really the data, and we need to have an approach, a structured approach, to actually ingest that data, organize it, process it, and deliver it, downstream to the relevant consumers, whether it be machine learning data scientists or analysts looking at business intelligence dashboards, or application just like contractor intelligence, basically where data is aggregated, worked on, filtered, cleaned, and redesigned in a shape that would fit the end use case of contractor intelligence. But this is fairly structured, but we don't only work with structured data. I mean, there's huge amounts of unstructured data. If organized and processed correctly, could really bring a lot of value. We're talking about images, videos, chats, emails, texts. You name it, right?
Mm-hmm.
And these basically, whether we want to exploit these, as in their form like that, or do some kind of processing that generate structure out of these things that we could use downstream, in, I don't know, time series models, provision, predictive models, etc. Today, I think we have, I mean, there's something new in AI every day, right? I mean, frontier models dropping, there's really a cold war happening right now, in terms of, foundation models, and these models are getting, better and better by the day. And these large language models, or the multimodal variants of them, could really, provide a lot of value, provided the unstructured sources. They're very good at looking at unstructured, data, and, making sense and helping, if orchestrating in agents, can help, generate the structured data we want to work with, in a more controlled, compliant, and auditable way, right? Downstream.
Yep.
So, yeah.
So I'll just note for those listening to this webinar that as part of the testing of contractor compliance, and I mentioned the example of kind of comparing it to that use case of if I went to ChatGPT. I myself have tested that, where I've gone to ChatGPT and tried that. ChatGPT did not have the answer I was looking for. It did not know. The data is not out there. And I only give that example as to highlight that ServicePower is leveraging tens of millions of service records. And to your point, chats, emails, you name it. And that's why I mentioned the ability to bring together all this potentially unstructured data to create that so that we can give that answer in the moment. So I think I just have one question left, because we've been going for a good amount of time here. If you're a leader in the field service world today, and AI, of course, is being driven through every organization out there, what would you advise those leaders, or what would you tell people, like, these are the things you need to be considering for the next year? This is where it's headed. This is the considerations as it relates to data. Because I do feel like that, I joked about the great data cleanse that we talked about probably a couple of years ago at ServicePower. That seems to be happening now. People are taking it seriously. So what's the next step? What are people going to need to have on their minds going into 2026 and 2027?
So I think, going forward, in my opinion, business leaders, I mean, I'm not saying any secrets here. Today, we need to embrace AI, especially agentic AI today, which is really going to have a transformative impact on how we do things. We need to keep an open mind and embrace, this new technology, and be open to new ways of doing things, right? I mean, look at the software engineer job. It is being revolutionized as we speak today. I mean, going from writing lines of code, test batteries, reviewing all these things. I mean, today, you basically, describe what you need to a couple of coding agents, steer them in the right direction, and you know, you basically have a contract with them. Uh, you know, uh, do your stuff. I mean, write your code, do whatever you have to do. I mean, between the agent and the developer is basically a contract. Tests need to be passing, right? I mean, sometimes you don't even bother to look into what has been written. I mean, we won't be able to review all the generated code line by line as we used to do. Otherwise, we will become the bottleneck because agents are so much faster than us, writing code and implementing features. So we need to look at our job in a different way. Similarly, for the leaders, I mean, this is an impact just for software engineering, but for other fields, I mean, there will be other impacts. Many workflows can be automated using agentic AI. What they need really to be focusing on really is the data they have. I mean, the data is really the moat of every organization. Really is that's exactly your most valuable asset right now, because expertise, different disciplines, you can implement, if AI is implemented correctly, I mean, you can really have a huge improvement, both in efficiency, in terms of skills as well, right? I mean, you can have AI do cover a lot of skills, but your most important assets, I mean, if you want to get value out of this AI implementation, it's hooking the AI to your own data and implementing your own processes. So it's important to look at the data, treat it as really the most important asset. Don't leave it lingering. Don't let data lakes become data swamps. Good governance, good cleansing pipelines, etc. Right. So that's what I would suggest.